Hello, I am Muralidhar, a teacher in mathematics for the last 55 plus number of years. I have worked in India for 25 years, for more than 30 years abroad. I have taught all syllabi, most of the world famous syllabi. Our Indian state level, ICSE, ISC, CBSE, and when you go to foreign, A levels, O levels, IB, AP calculus, GMAT, GRE, SAT 1 and 2. So like this, all courses I have taught, and thus I have gained a lot of experience. Now here, back in India, I am here to give coaching online to our students of any class starting from 8th to 12th. In the sense, even 7th to 12th. I am not teaching college courses, only up to grade 12. CBSE grade 12, PUC second year, our CBSE grade 12, state level PUC second year, like this I am teaching all. So today I just want to give an 8th standard lesson, and that is rational numbers. Usually, you are familiar with the natural numbers. A set of natural numbers means we start with 1, 2, 3, 4, like this, infinitely many. You can go on writing. This is set of natural numbers. And we have set of whole numbers. A set of whole numbers includes 0, 1, 2, 3, 4, dot, dot, dot. Remember here, natural numbers are counting numbers. We start with counting number 1, number 2. We don't say 0, 1. So, the 0 does not come in set of counting numbers or natural numbers. Whole number, 0 is a whole number. And no negative numbers are included. It starts with 0, goes on up to infinity. That is that. And Z is a set of integers. This can be -3, -2, -1, 0, 1, 2, like this. So it includes negative numbers also. This is called set of integers. Set of integers. Set of whole numbers. Here, natural numbers. Set of natural numbers. In this, every set which I have mentioned, it follows certain properties. Every number. Similarly, rational numbers also. Now, what is a rational number? Integers, you understand what it is. A number which can be represented in the form P by Q, where P and Q are integers and Q is not equal to 0. This is the definition of rational numbers. It is in the form P by Q. It is a fraction rather. P and Q are integers. So, any integer, for example, integer 1 or integer 2, 2 can be written as 2 by 1. 2 is an integer, 1 is an integer, and 1 is not equal to 0. Q is not equal to 0. They may say only 2, but it means 2 by 1. So, every natural number is a rational number. Suppose I take 4, 4 by 1. P is 4, Q is 1, 1 is not equal to 0, it is a rational number. Here, when you come, 0 is there. Is it a rational number? 0 by 1. 0 by 1? Yes, 0. It is an integer. It is also a rational number. So, all these are rational numbers. These rational numbers undergo some important properties. And we shall do those properties now. I hope you have an idea of what it is. If you want, as examples, you can write 4, 5 by 3, 10 by 7, 5 by 9. All these are rational numbers. 4 by 1, P by Q. 5 by 3, P by Q. Q not equal to 0. 10 by 7, 10 integer, 7 integer, 7 is not equal to 0. 5 by 9, 5 integer, 9 integer. Root 5 by 7. Root 5 is not an integer. 7 is an integer. But according to our definition, P should be an integer. Therefore, this cannot be a rational number because P is not an integer. Integer means whole numbers like this. Okay? Maybe positive or negative. That doesn't matter for us. So, what is a rational number? Any number which can be expressed as P by Q, where P and Q are integers, Q is not equal to 0. Sir, everything is fine, but why not Q is equal to 0? Okay, we know 1 by any number by 0 is infinity. What value it is, we don't know. It is so great. As the denominator decreases, the value of the fraction or value of the rational number increases. 1 by 10.1. 1 by 100.01. Value has decreased. 1 by 1000.001. If it goes on decreasing like that to infinity, which is such a big value which you can't imagine, then the value will be automatically close to 0. So 1 over 0 is not defined. Therefore, 0 should not be there in the condition Q is not equal to 0. Right? Now, we shall have the next part of it. This is rational number. Next part will be properties of rational.